Okay, LT6 is apply the Pythagorean theorem to find distances between 2 points in a coordinate plane. So I know you don't have this picture in your packet. I just want to use it to give a little background information about finding the distance between 2 points. So it says here that Vicky is standing on the corner of 7th Street and 8th Avenue. So here's Vicky, and her brother is on, brother Scott is on the corner of 2nd Street and 3rd Avenue. So here's Scott, and if they want to know the distance apart they are, if Scott wants to know how long or how far he has to go to travel to Vicky, one thing he could do is count blocks, right? He could count, okay, I go over 1, 2, 3, 4, 5 blocks, and then I walk up or north 1, 2, 3, 4, 5 more blocks. Okay, that's one thing that you could do. But typically, when we're talking about distance, we're going to talk about the shortest distance. So if Scott wants to get to Vicky the fastest route possible, kind of visualize in your mind the path that he's going to take. All right? He's not going to go over and then up. He's going to go along this diagonal, okay, and cut through the city blocks that way. That would be the shortest distance. And then what's nice is you can calculate that distance because it can become part of a right triangle. You can just connect the points and make a right triangle, and then we can use the Pythagorean theorem to find this distance. And that's what we're going to do in the next couple of examples. We're going to find the distance between 2 points on a coordinate plane. All right, so the first example, we can see here that we have the point 1, 2, and 4, 5. And if we want to find the distance between those 2 points, the first thing I do is I just connect them, the shortest distance possible, so that diagonal. And then I'm going to make it into a right triangle because that's going to help me visualize what's going on here. And then I'm going to label the parts of the triangle so I know that the C side, the hypotenuse, which is the C, is always across from the right angle. So this is the C, the hypotenuse. And then I'm going to call this A and I'm going to call this B. And now I can find the leg lengths by just counting on the coordinate grid. So I notice that side A is 3 units across, and I notice that side B is also 3 units. Now there's another way to do it, okay? We can look at the coordinates. If we look at the x coordinates, we're going from 1 to 4. If you travel from 1 to 4, you have to travel 3 squares across. And then we can look at the y coordinates to see the up and down part. They start at 2, or this point starts at 2, and then this point up here goes up to 5. And the distance between 2 and 5 is 3. So that's where this 3 is coming from, okay? And then the 3 over here is coming from those x coordinates. We start at 1, we go all the way over to 4, okay? So now I can go ahead and use the Pythagorean theorem. I'm trying to find c, so I know that c squared is equal to a squared plus b squared. And a squared is going to be 3 squared. B squared is also 3 squared in this case. So c squared is equal to 9 plus 9. C squared is equal to 18. Square root it. Square root it. So we could say that c, the distance, is equal to the square root of 18. And I know that's going to be between 4 and 5 because it's going to be between the square root of 16 and the square root of 25. So it's between 4 and 5. You can also give an approximate answer. So it's approximately equal to 4.24. And then that just keeps going. It's an irrational number. Okay. I would go ahead and give both of those answers. The exact, precise answer, and then more of the estimate of approximate value of how far that is. And then just look, does 4.24 make sense? Yeah, it looks reasonable. All right, let's look at the next one. We want to find the distance between, actually, that's the same one. We want to find, so example B. We want to find the distance between -5, 4, and 1, -6. Now notice these 2 points are already connected along the diagonal. So what I'm going to do is just draw in the rest of the triangle. Okay? So there's my triangle. I connected the 2 points. We could also connect them this way and have an upside down right triangle. Either way would work. So I'm going to label, okay, this is my right angle, so this is the hypotenuse, that's C. I'm going to call this side A and this side B, and now I just need to figure out how long those sides are. And I'm going to go ahead and use the x and the y coordinates. So this x is all the way over at -5. So this starts at -5 and we travel all the way over to 1. Okay, so that's going to give us a distance of 6, a length of 6 for this triangle. And then the height of this triangle, if I'm looking at the y coordinates, I see, okay, it starts all the way up at 4, and then we go all the way down to -6. So 4 and then 6 more, so that distance is 10, or that length of that triangle is 10. Now I'm trying to find C, that shortest distance. Okay, remember if like two people were walking to each other, they'd follow that distance. So C squared is equal to A squared plus B squared. This time my A is 10, my B is 6. So I have A squared is 100, B squared is 36. So C squared is equal to 136. And then the square root of that, C is going to be equal to, the exact answer is just 100, the square root of 136, because that is not a perfect square, but I could get an approximate answer, and I used a calculator. It's 11.7 approximately. Now sometimes you'll see people, if they're finding the distance on a coordinate grid, say units. So that's also a good idea. So there's my answer. I have the exact answer of the square root of 136, and then the approximation, because again, these are irrational numbers, okay? It's an estimate. All right, on to the next one. We have point -11 and point 62. So I'm going to connect those, shortest distance. There's the diagonal. And then I'm going to create the rest of the triangle here by connecting those 2 points. There's my right triangle. Draw in my right angle. Then here's the C, the hypotenuse. I'm going to call this A and this one B. And then let me use the coordinates again, the x coordinate. So I start over at -1 on the left and I travel all the way to 6. So I go 1, then 6 more. So that distance or length is 7. Okay. For the y coordinates, I go, I'm starting here at 1, up 1. And then I move up 1 to 2, so I just traveled a distance of 1, from 1 to 2. So my lengths of the triangle are 7 and 1. Trying to find C, so I'm going to use C squared is equal to A squared plus B squared. So I have 7 squared plus 1 squared. So C squared is equal to, that's 49. 1 squared is 1. So C squared is equal to 50. Square root it. This is another irrational number. It's not going to come out nice. It's not a perfect square. So C is equal to the square root of 50, which is approximately 7.1 units. Okay, that's a 7. All right, so there's how we can use the Pythagorean theorem to find distances in a coordinate plane. Told you that theorem was going to be pretty useful.